First up in Chemistry 2 is topic A, structure of the Earth. Now, fortunately, we've already covered some of this. So when we did physics, we were looking at earthquakes and we looked at the structure of the Earth a little bit in order to understand why different waves go different places. So, just got a little picture here to show you the Earth. So we've got the crust on the outside, then the mantle underneath, then the core inside, which can be split into the outer core and the inner core. It's kind of like an onion, I guess. We've got layers. Anything that has layers automatically gets compared to an onion, so that'll do. So we've got our thin rocky crust on the outside, and the crust does contain, the core contains iron. I've got a typo there. That should say, this bit here should say the core. So we start with the thin rocky crust, we go down to the mantle, and then the core contains iron. Hopefully you'll all remember it now because I've made such a horrible mistake. Anyway, the structure of the Earth has been difficult to find out about because we can only drill so far down, and that limits what we can find out because it gets very, very hot, so drill heads get destroyed and it's quite hard to dig too far down. So scientists have found out about the structure of the Earth by studying seismic waves, so the vibrations, the waves that were caused by earthquakes, to help us understand the structure of the Earth. Now, of course, earthquakes don't happen when we want them to, so another thing that scientists have done is set off explosions to create their own seismic waves so they can study where they go and what happens, and from those waves we can figure out what the structure of the Earth must be like. So the new word for this topic is lithosphere. So the Earth's lithosphere is the outer layer of the Earth. It's mostly the crust, but the top part of the mantle, which is still fairly solid, is also part of the lithosphere. Now the lithosphere is split into several big pieces, and these are the tectonic plates. There's two types of tectonic plates. There are the oceanic ones, which sit under oceans, and the continental plates, which sit under continents. And the plates sit on top of the mantle because they're very, very dense, so they just move up to the top, and they do move around. So they move by about 2.5 centimetres a year. And it's these movements that cause earthquakes and volcanoes. So earthquakes are when two plates sort of rub past each other, and volcanoes are caused when either a plate goes down or goes underneath or goes above another one. And that causes the volcanic eruption. So you'll find that there are more earthquakes and volcanoes along the boundaries of each of the plates. For the higher paper, we need to know a little bit more about plate theory. So we need to know that because the Earth's core is very hot, it gets hotter the deeper down you go. And as we get closer to the core, the mantle becomes a liquid. And because it's getting heated from the bottom, then we're going to be able to see convection currents, which will cause the mantle to move around. And it's these convection currents that cause the tectonic plates to move. And the other little bit that we need for higher is to know that oceanic crust is denser than continental crust. So if these two collide into each other, the oceanic plate will sink and a little bit of it will melt, which will often lead to a volcano, so the melted rock will get pushed back up again. But the name of this process is called subduction. So sub as in going underneath, and duction is from the Latin to lead, so it sort of gets led underneath. Don't know if that'll help you remember in any way, shape or form, depends how good your Latin is. Right, so volcanoes. Volcanoes are formed in places where magma can find its way through the Earth's crust, which, as I've said, often happens at plate boundaries. And the magma just rises up because it has a lower density than the crust, so it can just rise above it and come pouring out, basically. And the rock that erupts from volcanoes is known as lava. And there are different types of lava. We can get particularly runny lava, which moves quite quickly, and there's also thicker lava, which moves much, much slower. The thick lava comes from the really violent eruptions, but once it's sort of come out, it travels very slowly. Then, as this liquid rock cools, as the lava cools, it turns into a type of rock that we call igneous rock. And for the higher, we just need to know a little bit more about this rock. Igneous rocks are particularly hard, and they're made up of crystals, and they have different sized crystals which gives them different properties. So large crystals are made when the rock cools slowly, and small crystals are made when the rock cools quickly. So runny lava from slow eruptions forms iron-rich basalt. So that's a type of rock that can be formed from the runny lava. You just need to know that name, iron-rich basalt. And the thick lava from explosive eruptions can form silica-rich rhyolite, which is just another type of rock. So those are just two examples of igneous rock. You need to try and remember which type of lava they come from. But again, remembering the size of the crystals is the thing they're particularly interested in. And large crystals come from slowly cooling rock, so it's had lots of time to form fantastic, beautiful, big crystals. And the small crystals come when it's cooled quickly, so it's sort of formed in a rush and it's imperfections, so we get lots of small ones instead of a few big ones. And that is it for our first topic in chemistry. Hopefully it wasn't too terrifying since we've already done a bit. Remember, if you've got any questions, do not hesitate to ask me when you see me.